Okay, so when we say multiple ways to factor, what I'm going to do is I'm going to try to show two different routes to kind of get to the same answer here. The first one we're going to start with is the concept of a greatest common factor. We're going to just call that a GCF, okay, greatest common factor here. And in this case, what we're looking for is just a factor of all the values, something that they're all divisible by, and we're looking at the coefficients specifically, and the constant term at the end. And the reason for that is because it doesn't have a variable here. If it did, you could technically have a variable as part of the greatest common factor. In this case, we can definitely take 2 out. They're all even numbers. That's a really quick way. And you can continuously take numbers out and build your greatest common factor. So quickly off the top of my head, I'm going to say that, oh, actually, that is the greatest common factor. I was hoping to have more. So we can divide each of these by 2. Okay, so in our next line, we'll bring 2 to the outside and then set up a set of brackets. We'll open them. And 8x squared leaves you at 4x squared. Negative 24x, when divided by 2, leaves us at negative 12x. And positive 18 leaves us at the value of 9. And then we close our brackets. You'll notice we took the number 2 out, and then we're set. We have now our polynomial or our quadratic, depending on how you want to look at it. Now, that would be the greatest common factor. That's the first step. What we can then look at is we can then take a look at inside this bracket. There's a couple ways to go about this, depending on what you've been taught with factoring. This happens to be 2 and 3, 6 times 2. Yeah, this is known as a perfect square trinomial. And what's special about a perfect square trinomial is it happens to run into a scenario like this, where you have a squared. So the first term is some value that can be square rooted. The last term is also some value that can be square rooted. And then the middle term happens to be the square root of the first term times the square root of the second term times the number 2. That seems like a lot, but we're going to kind of run through this scenario. The reason I want to show you this, that it's a perfect square trinomial, is because when it is a perfect square trinomial, a really easy way to get the factored part of this is to just take the square root of the first and last terms and put them inside of a set of brackets. So for instance, we have a squared. If I ask, hey, what's the square root of a squared? It ends up being a. And if I ask, hey, what's the square root of b squared? It ends up being b. Okay, so what's neat about that is I can put a as the first term, b is the second term, and because it's a plus sign, I'm going to put a plus here, and then all I have to do is put a squared on the outside. It's a super fast way because it's a very specific trinomial. But I'm able to recognize that. How could you recognize it? Well, a way to do that is to run this little test here. You take this first term, 4x squared. Okay, what is 4x squared? Well, if we take the square root of 4x squared, we end up with 2x. Okay, then I'm going to take the last term, 9. Well, what's the square root of 9? That gives me 3. Okay, and remember, the middle term, that's this number multiplied by this number and then multiplied by the number 2 again. And if that ends up being the middle term, which is this thing here, then it is a perfect square trinomial, and we can really just skip to the end here. So 2, I'm going to write it down here, 2x multiplied by 3, I'm going to write over that, multiplied by the number 2, ends up giving us 2 times 3 is 6, times 2 again is 12, times x is 12x. And there we go. 12x is the exact term here. So very quickly I go, hey, this passes the perfect square trinomial test. So I don't have to go through a really long version of factoring. I can just set up one set of brackets. I find the square root of the first term, which we've already found to be 2x. The square root of the last term, which we already found to be 3. Now, I said we put a plus sign in here, but it's technically whatever the operation is in front of the middle term. And in this case, the operation happens to be a negative sign, so it becomes a minus there. And then we just add our exponent, power of 2, and then we have it. That's our perfect square trinomial. So one way we could do that is doing the GCF, and then I'm going to call it the PST. So those are our two styles of factoring we use for this. But I said that we use multiple ways, and technically that's two. But there's a whole nother way we could have gone about this question. Here. What did I find out to go wrong here? Oh, I didn't copy it over right. This should have been a positive number. So bring it up again over here. It was 8x squared minus 24x minus 18. Okay. Another way we could have gone about this is factoring. Now, one of the factoring styles I have is looking for products. There's a sum and product method is one. One I know, and there are so many different ways of factoring. I don't think I ever gave it a name, nor have I ever seen a name, but I'm going to show you this version. And this version is where you find the factors of both the first and last term. And the reason we do that, for instance, we have 8. So a set of factors of 8 are 1 and 8, and we also get 2 and 4. Think of them as if they're in their own little columns, okay? There's 2 little columns. And then I'm going to find the factors of 18. Well, 1 and 18, 2 and 9, and actually 6 and 3 are sets of factors. So I'm going to put them in their own little columns also, okay? The goal here, and if this is the first time you've seen it, it might seem a little tricky, is to find a column, one of these columns, to multiply by one of these columns to end up with 2 values that add to the middle term. And that is a mouthful to start with. But I'm going to go through this process with you, okay? So, and once you get the hang of it, I find this one actually be one of the fastest factoring methods. And again, we're always looking for whole numbers. We're not looking for decimal numbers because technically you can get decimal numbers and you can factor it. It just becomes very difficult. So we just look for natural numbers or technically integers when we're doing this. So eventually we'll get pretty fast at it. But I'm going to just start testing with the very first column. And what I'm going to do, I'm going to say, well, 1 times 1 is 1 and 8 times 18 is like 90 something. I could write 9 and 90 something here, but right away I know in no scenario are those going to add up to 24. That's not going to work. So I'm just going to get rid of those. That doesn't work. And then I can technically do the cross also. I can do 1 times 18 and 8 times 1 gives me 8. 18 and 8, if one's positive and one's negative, no, it still doesn't really work. We end up with like 26 or 10. It doesn't really work that scenario. So I know that the first column times the first column doesn't work. And then I repeat this column times this column. 1 times 2 is 2. 9 times 8 is 72. And that's not going to work. And eventually you'll get really good. You'll find this much quicker. Let's do 8 times 2 is 16. 9 and 1. 25. We're getting close, but not really. I'm going to exhaust my options just because I want to show you the long way of doing this method. 6, 8 and 3 is 24. Definitely that's never going to work. 8 and 6, 1 and 3 gives you 3, 48. That's never going to work. So what I've just done is I've exhausted all the options of the first column. So I know it's not the first column. So I now know it's for sure this column here. It's going to be 2 and 4. And I just got to figure out which of the secondary columns it's going to be. So I'm going to quickly go through this one now. Okay, so 2 times 1 and 4 and 18. That's going to give me 2 and 50. No, even higher than that. That's not going to work. So we jump back a little. Oops. What did I hit there? Let's get out of that. Okay. There we go. And if I say 4 and 1 and 2 and 18, 18 gives me 36 and 4. Even if I subtract, that doesn't work. So we're jumping out. And now what I've done is I've exhausted this column too. So we're really getting to the bottom of it. Unfortunately, it's going to be one of the last ones we try here. 2 and 2 and 4, and that gives you 4. 36, not quite. And if we go the opposite here, 2 and 9 is 18. 4 and 2 is 8. Doesn't quite work either. So apparently we've exhausted 2 sets of columns. It's got to be some version of this. 2 times 6 is 12, and 3 times 4 is 12. Hey, that works. Okay, so we've discovered that this scenario is going to work. Remember, it's negative 24. So in order for this to work, it needs to be negative 12 and negative 12. In other words, these two last terms both have to be negative because I have to make sure the product, 2 times 6, becomes negative 12. So I'd say 2 times negative 6. And, oh, actually, I found an error here. 4 times 24. No, that doesn't make sense. Uh-oh. The reason, what I've discovered here as a mistake is the other way to check is these two values have to multiply to this number here. And if I have a negative times a negative, that should give me a positive. So actually only one of these should be negative. So I hope I didn't skip one of the actual older answers there. I should have only had one of these be negative. Oh, nuts. The only thing is this makes a lot of sense because you get 2 12ths. That means I have to go through this whole thing again. What I'm going to do is I'm going to skip that. We're going to circle back to that one. I don't know where I missed on this. Another version of factoring, which you might be more common to or more familiar with, is called sum and product. And the sum and product is where you take this middle term and you decompose it. You do decomposition, they'll call it, and you're going to decompose that middle term. And in order to do that, you're going to look for two values that add up to 24, negative 24x. So on the side here, one of the things we can use is, well, negative 12x and negative 12x work. So we're actually going to replace negative 24 with those two values. We'll end up at 8x squared minus 12x minus 12x minus 18. Now what we're going to do is we're going to kind of try to imagine these as like two sets of terms, okay? And the first set of term, I'm going to look for greatest common factors. Now there's an x in here, so I'm going to take an x out. And as a factor, the number 4 works very nicely. So if we take 4 out, we divide each of these by 4x. Okay, we get 4x. 8x squared divided by 4x is actually going to give us 2x. And negative 12x divided by 4x will give us negative 3. Okay, and then in our second set of terms, we don't have an x we're going to take out, but we can take out the number 3. Yep, the number 3 is going to work here. Is it the best one? Can I go 4? No. 5, 6. Ah, there you go. I can also do 6 here. 6 works even better. It would be, you're usually trying to find the greatest common factor here. So I'm going to go with 6. And not only am I just going to go with 6, but I'm going to go with negative 6 just because both of these happen to be negative. So I'm going to take negative 6 out of this. And negative 12x divided negative 6 will give us positive 2x. And negative 18, oh, I wonder, mistake. So the reason this doesn't work is this is supposed to be positive. I was wondering what went about that, Nathan. So I can circle back to our answer here, and this one will actually work. But let's continue with what we got here. If we take a positive 18 and divide negative 6, it should be negative 3. And the reason I caught myself again is because what I'm looking for is two sets of brackets that are identical. I knew when I was reading this that if I divided by a negative, this would have been a positive value, and these sets of brackets wouldn't have been identical. So I knew there was something wrong, especially because we'd already solved it the first time. Technically, what we do next is greatest common factor these two brackets out, but the easiest way to think about this step is just set the first set of brackets equal to those two, so you get 2x minus 3. And then the second set of brackets, just put the two greatest common factors inside that bracket. So 4x minus 6. Technically, I can continue. I can common factor the number 2 out of these. And we can end up with 2x minus 3, 2 on the outside, and then 2x minus 3 again. Okay, let's shrink this a little. There we go. And what's nice about that is we get the number 2 on the outside. We get 2x minus 3, 2x minus 3. Because those are the same, we get 2 times 2x minus 3 squared. That's another way of factoring. Technically, this method would have worked because that would have been positive. These two negatives worked. And I'll just show you the end result of that. When I finally pinpoint my two columns, I set up two sets of brackets. I put technically there's an x in here. I'm going to put the 2x in one set and the 4x in the other. And then whatever I multiplied by, I know it's been a while since we talked about this one. Because I did 4x times negative 3, I put the negative 3 in the opposite bracket of 4x. So 4x is here, negative 3's got to go in this bracket. And because we multiplied 2x times negative 6, 2x is here, negative 6 goes in the other bracket. We end up in the same scenario where I can common factor the number 2 out of this, so we already know how this is going to turn out. We're going to have two sets of 2x minus 3, which means we're going to square that in the end.